name is Gianluca Mardente. I'm a principal engineer at Cisco Systems, and I've been working on Kubernetes for the last 5 years. I started at Tagera, which is the company behind Project Calico, and I went to Cisco and kept working there on Kubernetes. And on the side, I've been maintaining this open source project, which is called Project Sveltos. I've been working on this for 18 months now. As you know, when you create a Kubernetes cluster, you need to deploy add-ons and application to make it a production cluster. There are tools that allow you to programmatically create, upgrade, or delete a cluster. Cluster API is becoming probably the standard there. And Sveltos is a tool that can be used on top of it to programmatically manage add-ons and application in a fleet of clusters. So Sveltos runs in a management cluster, and cluster profile is the main CRD which is introduced by Sveltos to be instructed on what to do. And from there, Sveltos can manage a fleet of Kubernetes clusters. Now, those clusters can be cluster API powered cluster. Sveltos has built-in support for cluster API, meaning that if you create a cluster API powered cluster, there is nothing else that you have to do. Sveltos automatically detects this cluster and is able to manage it. But if you have any other type of cluster, you can simply register with Sveltos, and then Sveltos can manage from that point on. In the demo that I have prepared, I create like a GK cluster, and we'll have Sveltos manage like this GK cluster. The only things that Sveltos requires is a network connectivity from the management cluster and those managed clusters. How does Sveltos work? Cluster profile is the main CRD, and it has in its spec section a cluster selector, which is just a Kubernetes label selector. It's selecting all the clusters where the add-ons needs to be deployed. In this case, it's selecting all the clusters which have label, environment, functional verification, FE. And then it has three sections: Helm charts, customization refs, and policy refs. The Helm chart section, it's a section where you can have one or more Helm charts that needs to be deployed. In this case, we are asking Sveltos to simply deploy Caverno version 2.6.0. The customization ref section is a section where you can tell Sveltos where to get the customized file. In this case, we are telling Sveltos to get this customization file from a Git repo. Git repo is synced with Flux, and then Sveltos will use the content of this Git repo to run the customize SDK, get the resources that needs to be deployed, and deploy the resources in all the clusters matching the cluster selector. And finally, there is a policy ref section. Sometimes it's convenient to put your configuration, your YAML and JSON in a config map data section or in a secret data section. Referencing the config map or secrets from here, we'll have Sveltos get the content of this config map and secrets and deploy the content in all the clusters matching the cluster selector. This is an example of a config map where in the data section I have stored a gateway class and a gateway. So if there were a cluster profile referencing this config map, Sveltos will take the content of this config map and deploy it. So it will deploy the gateway class and the gateway in all the clusters matching the cluster selector defined in the cluster profile. Here I have a slide where I'm summarizing with some animation how Sveltos works. So we start by posting a cluster profile, and we're telling Sveltos find all the clusters which match the cluster selector environment prod, and deploy Caverno version 2.5.0 in all such clusters. So if we add the label environment production in the first workload cluster, Sveltos is going to detect that this cluster is a match, and because this cluster is a match, it's going to take all the add-ons and applications listed in this cluster profile, in this case just Caverno Helm chart, and it's going to deploy it. As simple as that. So if we add the environment production label on the second managed cluster, same thing's going to happen. Automatically, Sveltos will detect that this cluster starts being a match, and it will deploy Caverno on this cluster as well. The same way, Sveltos can be used to deploy add-ons and application in managed clusters. Sveltos can withdraw those add-ons and application. For instance, If we remove the label environment production from the second main workload cluster, this cluster stops being a match, and so Sveltos is gonna withdraw Cavern. This behavior though is configurable. This is the default behavior, but Sveltos can be configured to leave the add-ons and applications that he has deployed on a cluster when the cluster stops being a match. And you will use this use case if you are creating a cluster for a tenant, for instance, and you want to pre-populate these clusters with a set of add-ons and applications, but then you let the tenant decide whether he still wants this information or not, those add-ons and applications or not. Now, one of the main reasons why I developed Sveltos was that I wanted like something which was dynamic in nature. Dynamic in nature means that I want all the add-ons and applications, Helm charts or content, the YAML or JSON passed like in the config map or secrets to be expressed as a template. And Sveltos, it's able of instantiate those templates at deployment time using information which are coming from the management cluster. Here is an example. I want to deploy Calico in all the classes which are matching the label environment production. Now, Calico needs the port header blocks, so I can achieve that. I add a value section to this Helm chart, and this value section, it's expressed as a template. I know that if I'm about to deploy Calico in a cluster which is powered by Cluster API, I know that in the management cluster, there is a Cluster API cluster instance representing that cluster, and in its spec cluster network pod header, it contains the pod header blocks. So what I'm telling Sveltos is, when you're about to deploy these Helm charts, take this resource, which is present in the management cluster, take this information from this resource present in the management cluster, instantiate this value section, and only then deploy the Helm chart. By default, Sveltos can fetch certain resources in the management cluster. Cluster API resources like the cluster instance, the infrastructure provider instance, the KubeAD and control plane, or the Sveltos cluster instance. But essentially, Sveltos can be instructed to fetch any information from the management cluster, provided that Sveltos is granted the permission to do so. In this example, I'm asking Sveltos to deploy the content of this config map, which is in the default namespace called info. But before Sveltos does that, I want Sveltos to fetch this secret, which is present in the management cluster in the default namespace, and it's called autoscaler. And I want to identify these resources autoscaler secret. So if we look at the content of the config map is a template. There is this annotation which indicates Sveltos that the content is a template, and this template is actually using the identifier autoscaler secret, and then it's using the data token and CA/CRT. So it's using like information which is present in the secrets present in the management cluster. So what Sveltos is going to do, it's going to fetch the secrets present in the management cluster, it's going to instantiate this template, and then deploy the instantiated template in the managed cluster matching the cluster profile. Because of this dynamic nature, Sveltos being able to fetch resources from the management cluster, Sveltos can also be used to coordinate other open source projects. I want to mention that on top of reading resources from the management cluster, Sveltos can also create resources in the management cluster. So in this example here, we're using Cluster API, Sveltos, and Crossplane all together. We're using Cluster API to programmatically create a cluster. Once the cluster is created, we are posting a cluster profile, and this cluster profile, it's asking Sveltos to first deploy a crossplane bucket in the management cluster. Now, because we are deploying the crossplane bucket in the management cluster, we are triggering crossplane, and crossplane will go and create a Google storage bucket. And when done, it's going to update the crossplane bucket status. What Sveltos is going to do at this point is going to fetch the crossplane bucket status. The crossplane bucket resources is going to take the status, the information present in the status section, and it's going to use this information to instantiate pod template with the bucket URL. The pod template was also present in the cluster profile. And then it's going to deploy the instantiated pod in the managed cluster. And because now this pod has the information as the bucket URL, pretty much you can upload the file to the bucket, to the Google Search bucket. So in this case, we're using Sveltos to coordinate crossplay before deploying, and then uses the information that coming from crossplane to instantiate a template and deploy a pod in the managed cluster. Another example would be to use Sveltos piped with external secret operator piped with Sveltos. So external secret operator, it's an open source project that can fetch secrets from external secrets management system. In this case, we are having the external secret operator fetches secrets from the Google Cloud Secrets Manager, and it's going to bring these secrets into the management cluster. And then we tell Sveltos to take this information, which is coming from the external secret operator in the management cluster, take it to deploy to the managed clusters. So it's going to deploy to the cluster API Power cluster and to the GK clusters. Sveltos also has an ability to detect any configuration drift. So let's take an example to explain what that means. Let's say that we are telling Sveltos to deploy Caverno in any cluster which is matching the label environment production. Okay, like the typo here. This should be environment production to match this cluster selector. There's a typo in the slide. But essentially, as soon as this cluster matches like this cluster selector, Caverno gets deployed. And a Sveltos agent gets deployed as well because we have the sync mode to continuous with drift detection. And now, because this other cluster is also matched, Caverno gets deployed in this other cluster as well. Now, what this Sveltos agent is going to do in this case is going to watch for all the resources that Sveltos has deployed in this cluster, and this Sveltos agent running in this other cluster is going to watch for all the resources that Sveltos has deployed in this other managed cluster. So if someone now comes and issue this command to delete deployment of namespace Caverno of Caverno directly to the managed cluster, what is going to happen is that the Caverno deployment is going to be deleted. Now, the Sveltos agent, which was watching for the sources deployed by Sveltos in this cluster here, is going to detect that this is a potential configuration drift. And so it's going to notify Sveltos running in the management cluster. And the Sveltos reaction will be to reconcile back and put Caverno back. So if you tell Sveltos that this is how you can make sure that no matter what happens in the managed clusters, the resource, the state of those managed cluster, it's always in sync with the state defined in the management cluster. Sveltos has also another capability to classify clusters based on their runtime state. Let's say that I want to deploy Gatekeeper on any cluster running a Kubernetes version greater or equal than 124, but strictly less than 125. I can introduce a second CRD clock classifier. What this classifier instance is saying is find all the clusters which are running a Kubernetes version greater than or equal to 124, but strictly less than 125. If you find any such cluster, add this label to the cluster Gatekeeper v39. And then we pair this classifier instance with a cluster profile instance that says, like, if you find any cluster running with matching this cluster selector Gatekeeper 39, which is exactly the same labels here, then deploy Gatekeeper version 390. So what is going to happen when I do that, when I post this classifier cluster profile pair, that this Sveltos agent is going to detect that both clusters are a match for this cluster profile because they are for this classifier, because they are running Kubernetes version 124.2, which is greater than or equal to 125.0, but strictly less than 125. And because of that, this label Gatekeeper 39 is going to be added to both the clusters. Now, because this label has been added to both the clusters, those clusters become a match for this cluster profile. And because they are a match for this cluster profile, all the add-ons listed in this cluster profile will be deployed. So Gatekeeper 39 gets deployed in both the clusters. What happens if now I want to deploy upgrade gatekeeper to version 3.10.0 if the cluster gets upgraded to a version which is Kubernetes version which is higher or equal than 125. Well, I can post another combination, another pair of classifier profile. I can have a classifier that says if you find any cluster which is running a version of Kubernetes which is greater than or equal to 125.0, the label that the cluster should have is gatekeeper b310. And then I pair this classifier instance with a cluster profile instance that says if you find any cluster matching the cluster selector gatekeeper 310, then I want gatekeeper 310 to be deployed in such cluster. So let's see what happens if this cluster here gets upgraded. If this cluster gets upgraded from 124.2 to 125.2, this cluster will stop being a match for the old classifier. It will start being a match for this new classifier. Because a match for the new classifier, the label gets updated to gatekeeper v310. And because the label is updated to gatekeeper v310, now this cluster stop being a match for the old cluster profile and starts being a match for the new cluster profile. And so the gatekeeper version gets upgraded to 3.10.0 by Sveltos automatically. So Sveltos has many other features, but it will take like too long to cover all of them. So done with the slides, but I have prepared like a demo. I do have a cluster, management cluster where Sveltos is running. So this management cluster, I can see that I have cluster API and Docker is infrastructure provider, and that I have Sveltos running in this cluster as well. And I do have one cluster API power cluster using Docker as infrastructure provider. And I do have a GK cluster which is registered with Sveltos. Now, Sveltos comes with a CLI which is called Sveltos Collab. Right now, the show add-ons command simply display what add-ons are deployed where. As of now, nothing is deployed. I do I'll show that body cluster. So if I look at the cluster, show labels. The cluster here I have the label environment production, and also the GK cluster has the label environment production. So this label is set on the cluster. And I do have cluster profile, which is saying that if you find any cluster with label environment production and both those clusters are a match, deploy Caverno 3.0.1. So I'm going to apply this cluster profile. As soon as this cluster profile is applied, because both the clusters are a match, I expect that Sveltos deploys Caverno in both the cluster. So if I use the show add-ons Sveltos Collab command, we should see that Sveltos deploys Caverno in both the clusters. And we can see that Sveltos deployed Caverno version 3.0.1 in the cluster API power cluster, which is in the default namespace called cluster API workload. And soon it's also deployed Caverno in the GK cluster. Now, so this is one example. I also have prepared like this classifier, which is saying if you find any cluster which is running Kubernetes version greater than or equal to 127, add this label version 127. And I'm gonna pair this cluster, this classifier with a cluster profile, which is saying if there is any cluster with version 127, then deploy Nginx. Now, what the clusters are a match for the classifier, because if we look at the cluster, it's running Kubernetes version 127.0, and if I look at the Sveltos cluster in the GK cluster, it's running a version 128.0. So I can apply the classifier, and I can apply the cluster profile. Because I applied bot, what I expect is that Nginx will be deployed like on bot. And as we can see, Nginx has been deployed like in the cluster API cluster. It's also deployed like in the GK cluster. So this concludes also this demo. If you want to find any information, including all the YAMLs that I use like in the presentation, for instance, like on how to integrate cluster API, Sveltos and cross-plane, or how to integrate with the external secrets management, all those YAMLs are present in the project Sveltos documentation, which is project.sveltos.io. So go to project.sveltos.io, like that's the main page. Or you can also visit the GitHub page if you have any information. And if you have any questions, you can join the Slack channel or reach me on mail or on LinkedIn. I want to thank you for your time, and I hope that you like this presentation. Thank you so much.